Today we'll be learning the basics of designing a robot. Here are the things we're going to go over. We'll start by talking about the qualities of a good robot, then move on to what you need to know to make one. So what makes a good robot? Well, there are many ways to define a good robot, but this is what we'll be using. The obvious thing is to complete as many missions and therefore get the most points. But a good robot is also consistent and does the same thing every time. It should rarely break and also should not be overcomplicated. A bad robot would not have any of these qualities. Now let's talk about how to make a good robot. When designing a robot, you have to find the compromise between strength and weight. One of the biggest ways to make a bot sturdy that does not take much weight is to always have at least 2 points of connection. This could mean 2 pins between beams or 2 holes for an axle to go through. Another way to improve sturdiness is to add extra support to load-bearing components. Some examples of load-bearing components would be wheels, heavy attachments, and the structure holding the EV3 brick up. Unfortunately, more strength generally means more weight, and that could cause problems. The heavier your robot is, the harder it is to turn and the faster your battery will drain. Axles can even become permanently damaged if your robot is too heavy. You have to find the middle ground and design your robot based on your needs. Motors are what power everything that moves on your robot. There are 2 types, the large motor and the medium motor. The large motor is stronger but also takes more space and is heavier. Large motors are often used for turning the wheels that move your robot. The medium motor is not as strong but is much smaller and lighter, so it is frequently used for attachments. When neither motor gives you exactly what you need, you can use gears. Powering a large gear with a small gear is called gearing down and makes the output slower but with more torque or power. Gearing up is when you power a small gear with a large gear, and that gives more speed but less torque. In the image, the green gear is the one powering the red gear. Different gearing is used for different purposes. Gearing up gives your robot more speed, but you have less precision and you can't push as much weight. Gearing down makes your robot slower, but makes it easier to make precise movements and allows you to push more weight. When designing a robot of your own, you must first determine what you want your robot to be capable of, and then decide what kind of gearing to use. Attachments are a big part of FLL and allow your robot to achieve more functionality. Instead of one robot that can do everything, you have attachments that go onto your robot and serve specific purposes. You then swap them out between missions so they have to be quick and easy to interchange. Passive attachments work without needing power from a motor. They are often simpler than active attachments, so there is less things to go wrong. However, there are many complex actions that they can't complete or will take too long to do. Some examples of passive attachments would be a plow to push elements or a hook that picks up an element as you drive by. Where a passive attachment won't work, you can use an active attachment. Active attachments use a motor so they have more flexibility. The downside is that because they're more complex, there are more things to go wrong. Some examples would be a moving arm that can push a switch on an element, or a claw to pick elements up. So as a quick review, the design you choose will depend on what you want to accomplish. You have to find a compromise between a heavy robot and a strong robot. You must find the correct gearing for your needs, and you have to balance the simplicity of your attachments with their capability. But, most importantly, remember to have fun, because that's what FIRST is all about.